Hey, Papa here. We're talking now about the felsic lightweight, light-colored rocks that are in the very top of a big stratovolcano like Mount St. Helens or Mount Lassen. That lightweight magma, which is mostly quartz and potassium feldspar, floats up to the top of the volcano and plugs it up. And so pressure starts to build. Pressure starts to build from down below because all that subducted ocean crust is pouring down to the mantle down there and melting and then rising up to form more and more pressure underneath that plug of quartz and potassium feldspar. And eventually, what do you think happens? Yes, kablam! There's a huge, gigantic explosion. So quartzy feldspar stuff of all sizes blows out of there, from dust, volcanic dust, to hunks of rock the size of a sofa or a Volkswagen, and they go spewing out across the land and cause a lot of damage if civilization is near. So let's look at some of that stuff. Let's say that stuff, that lightweight felsic material that's plugging the volcano, is mostly quartz. Then you're going to get a layer of something that looks something like this, and that's called tuff. Quartz-rich tuff, and there's a lot of this out west. It's just hunks of quartz rock, mostly quartz rock. It can be of all sizes, and it blows out of the volcano and settles hot across the land. Or if it falls into water, it cools off and welds itself together to form welded tuff, but it's mostly quartz. This is a piece of quartz tuff from a volcano out west, and I'm not sure where I got it, but maybe it was from the Mount Lassen area. So if you got mostly quartz, you're going to get that. You can find quartz-rich tuff here in Georgia and in the Piedmont of the eastern United States, going all the way up. What's the Piedmont? It's the part of the eastern coast that's between the mountains and the coastal plain. But it's metamorphic tuff. So let's look at some metamorphic tuff. And this is an example of quartz-rich metamorphic tuff. Metatuff is what they call it. This is hard to see, but it's mostly quartz. There's some other stuff in it, but it's mostly quartz. Okay. There's a piece of the Piedmont called the Carolina terrain. We can talk about that later, but Carolina terrain is just just north, maybe 100 miles north of the fall line where the coastal plain starts, and it's got a lot of this felsic quartz-rich tuff in it. Also, we call it metatuff. Mostly quartz. Now, you can have tuff that has mostly feldspar in it. And here's an interesting example. Does that look green? I don't know if it's really green or not. It's a lot of white stuff. What do you think that white stuff is? It's hard to say, but based on what we know now, we'd say feldspar, and you would be right. But this is feldspar that's been metamorphosed by the addition of water. In other words, this tuff, and you can see some gray quartz in there too. So this is like a quartz feldspar mix of tuff. This was blown out and definitely went into water because and maybe hot water, because the feldspar is getting kind of white and powdery. I can see how I can scrape it off like that. That white stuff is called cerussite. It's just potassium feldspar with water added to it, chemically, not just physically water added to it. So that's a tuff blown out of a volcano, a mix of quartz and K-spar. So now let's look at here's a interesting piece of tuff. Not metatuff, but tuff from out west in Idaho, in a town called Ashton, Idaho. Why do they call it Ashton? Because this ashy stuff was blown out of the like the Yellowstone volcano or its predecessor, and it fell on the earth And the feldspar, see the little gray dots? What do you think those are? Those specks are hunks of quartz. But the other stuff, the matrix that the quartz is embedded in, is kind of spun out feldspar, potassium feldspar. It's been kind of stretched by maybe its passage through the air, or air bubbles that were, gas bubbles that were in it, stretched it. But this is very lightweight, and we would really call this pumice. I don't know if this would float, but it might come close to floating. It's really, really lightweight. It's because of that spun out characteristic of that feldspar that these quartz pieces are embedded in. But definitely felsic, which means lightweight, light in color, blown out of a volcano, that it lodged in the top of the volcano with pressure. It was blown out. So that is your quartz and feldspar tuff. Okay, after that tuff blows out of the top of a volcano, you can get some eruption of lava, actual lava. But this lava is not the Black Hawaii lava yet. No, it is felsic lava, rich in quartz and feldspar. Is it granite? No, it doesn't have, not technically, I guess, because it doesn't have biotite or muscovite, but it's very close to granite. What happens is that if you have magma and lava that's made of quartz and feldspar, it forms a magma that's very thick. It's just like cheap toothpaste. It's thick. Whereas the Black Hawaii lava is very thin and flows easily. The fact that this lightweight felsic quartz and feldspar-rich magma lava is thick, that's what causes it to plug the top of the volcano and cause the explosion. But anyway, after the tuff comes out, you get what is called dacite lava. Dacite is just lava made of quartz and potassium feldspar. And here's an example of some dacite lava. Okay, and so what you get with this dacite lava is you get a matrix of very fine-grained quartz and feldspar mixed together, but you get hunks of quartz and feldspar in there. Like, see the kind of blue-gray spots? That's quartz, hunks of quartz, phenocrysts, they call them. That just means a large hunk. And then see the white spots? There are more that you can't see. Here's a bigger one. These are the potassium feldspar spots. And this forms a thick, slow-moving lava called dacite. And it bubbles out kind of slow and does not run very far at all. But you can get large hunks of it. So that's what comes out next. Let's look at some more dacite. Here's some dacite lava. And this really, I don't have any pure dacite. What I'm showing you is metadacite. It's just dacite lava that's been subjected to heat and pressure later on, but it looks very similar as far as I know. Okay, so can you see the matrix and then the spots of quartz and potassium feldspar embedded in the matrix? That's dacite lava. But when it's underground, when it's magma before it comes out, you could call it granite. But once it comes out, you can't call it granite because granite is an intrusive rock. When it comes out, it's extrusive, and we have to call it a kind of lava. So dacite lava is what we call it. And I think here's another specimen. This is pretty good. You see the white potassium feldspar spots and the bluish-gray quartz spots? This is also metadacite from around here in the Georgia Piedmont. Okay, so just in review, when you have continental crashing, you get these big giant stratovolcanoes that are explosive like Mount St. Helens. And inside that volcano, if you cut it and do a cross section, you've got really dark, heavy magma at the bottom. You've got intermediate magma on top of that that's either grayish or it could be white and black speckled, and at the top you've got the light colored felsic lightweight magma that contains almost exclusively quartz and potassium feldspar. And if that lightweight magma lava explodes and blows out, we call it tuff, or it can be quartz-rich tuff. It can also be quartz and potassium feldspar tuff. And it can. We also call it, if it's really lightweight with the spun feldspar, we can call it pumice, and it even floats because it had a lot of gas bubbles in it. And then after that blows out, you get thick, cheap toothpaste like lightweight, light-colored felsic quartz and potassium feldspar-rich lava called dacite lava. Okay, that's enough for now. Papa out.